Hi guys, we are continuing the 7, 4, 7, 7, 7, 8. I think actually it goes all the way to 7, 8 notes. So this can go right under what we did yesterday. So what we're going to do now is we're really going to set up how to factor, something called factoring by grouping. But before we do that, we're going to set up some problems to kind of get our brains working. So what you can copy down, because it might be difficult to draw 4 squares, is you can just draw a big X, okay, big X, so that you have 4 distinct sections. So you have above, to the left, below, and to the right. Okay. And so when we start factoring by grouping, what I want you to remember, and these variables will mean something when we put some actual numbers to it, but we have a trinomial in this specific form. So ax squared plus bx plus c. And what we're going to do is we're going to set up our big X so that a times c, so multiplication, a times c is going to go at the top, and b is going to go on the bottom. Okay. So the goal is to find numbers, because we will have actual values for a, b, and c, to find numbers that will go on the left or the right spots that are going to multiply to a times c, so that are factors of a times c. And at the same time, these same numbers, whatever they are, they also add to b. Okay. So let's say that again. The numbers that we find, which will go right here, we're going to find numbers that multiply to a times c, but at the same time add to b. So if we have some numbers, so let's copy down just at least 1 through 4. Maybe we might do more. So remember, instead of drawing the squares, you could just draw an X. Put 8 at the top and 6 on the bottom. So we're trying to find numbers that multiply to 8, but at the same time add to 6. Okay, so you might know what the numbers are right away, but if you're having a hard time thinking of the numbers, then what you can always do is you can list the factors. And we're going to list the pairs of numbers. I'm going to call them factor pairs. In fact, I'm going to write it up here where I have a little bit more room. So we're going to list factor pairs when it's necessary. And oftentimes you will find that it is necessary, because you might be thinking about it's hard to think about 2 things at the same time. 2 numbers that multiply to 8 but at the same time add to 6. So the numbers that multiply to 8 are 1 and 8 and 2 and 4. And that's it. So we're looking at integers only. And in fact, most times we're just going to be thinking about positive values at first. So the numbers that multiply to 8 but also add to 6 at the same time are 4 and 2. 4 times 2, when multiplied together, equals 8, and 4 plus 2 equals 6. So let's actually skip to number 3, because it's slightly more traditional. So we want numbers that actually multiply to negative 20, but add to 1. Initially, I'm going to ignore the negative. And I'm just going to list my pairs of numbers that multiply to 20. Then I'll worry about the negative symbol. Okay, so pairs of numbers that multiply to 20. 1 and 20, 2 and 10, and 4 and 5. Okay. So now let's think about the negative. So I've listed my pairs, but I want negative 20. So that means that in each pair of numbers, one of them has to be negative in order for it to multiply to negative 20. So for example, either the 1 could be negative or the 20 could be negative, but not both. Okay. So which numbers multiply to negative 20, which we have listed here, but also add to positive 1? So I'm going to be dealing with 4 and 5, because those are the only two numbers that are close to each other. If I make 5 negative, well, those are going to add to -1. So that's not right. It has to be -4. So it's going to be -4 and +5. There's only going to be one combination of numbers that works. You're never going to get, maybe there's going to be two sets of factors that work. That's never going to be the case. So -4 times 5 is equal to -20. And at the same time, -4 plus 5 is equal to +1. Let's take a look at 2. So again, our rule is that these numbers multiply to each other, and we're given these outside numbers, the left and right numbers. So if we multiply them, we'll get the top number. And if we add them, we'll get the bottom number. In fact, I'm not going to do 4. I'm actually, like I said, I'm more interested in these ones down here. So actually 6, 7, and 8. So I want you to take the time to think about what numbers multiply to the top values and add to the bottom numbers. And also keep in mind that we may, and I don't remember for sure, we may get an answer that actually, or a problem that we cannot find numbers to. And sometimes that does happen. So take some time and do 6, 7, and 8. Go ahead and pause the video, and when you think you have answers for all 3 of those, then unpause and check. So numbers that multiply to 12 but add to -7 are going to be -4 and -3. So one thing that you can kind of pick up on is that if this top number is positive, that means that they have to have, the numbers that you need to find have to have the same sign. And so when you add -4 and -3 together, you get -7. For 48, what would that be, 12 and 4? Positive, they both have to be positive because 12 times 4 equals 48, and 12 plus 4 equals 16. So +25 and 0. Some of you might have -5 and 5. Because that adds to 0. But the problem with that is -5 times +5 is not +25. That's -25. And if we think about the possible lists of, or possible factors that multiply to 25, it's just 1 and 25 and 5 and 5. So 1 and 25, no combination, whether you put whether you have a positive or a negative value, that's never going to be 0 when you add it together. So that means that we actually cannot find values for this. Just right, not possible.